Now in this lecture we are trying to learn what is context-free grammar is. It is defined as G is equal to V T P S, where V is nothing but set of non-terminals, where these non-terminals can be represented with all capital letters, and T is represented set of terminals, whereas terminals is nothing but all small letters, small case alphabets, and as well as a special symbols you can represent with non-terminals, or else numerics 0 or 1 numeric values can also be you can represent it with the help of terminal, where P is nothing but set of productions. If any of the rule is of form A tends to alpha, you can say that this is a production where A is nothing but A should belonging to V, which is nothing but A should be non-terminal, whereas alpha can be a terminal as well as non-terminal. It can be, or else both the combination of any combinations of terminals and non-terminals. This alpha can be RHS of the production can be combination of non-terminal and terminal, whereas LHS of the production must be a non-terminal. And what is S here? S is nothing but the start symbol. S is nothing but the start symbol. Let us suppose say I just wanted to define context-free grammar for the language which is accepted by any number of A's. See, this is my language rule. See, the language rule is I just wanted to construct context-free grammar for any number of A's. This is the language rule. Initially, whenever the grammar rule is given, you need to construct regular expression for this grammar. Any number of A's, which means that it can be 0 number of A's. In those cases, regular expression will be epsilon. Any number of A's, if 0 number of A's means epsilon. 1A means A. If n value is 0, epsilon is the result. N value is 1, A. If 2 means AA. If n value is 3 means AAA. Right? Likewise, the regular expression can be constructed in this form, right? That means that there is a possibility of epsilon, right? That means that from the start of the production, S is my start symbol, right? From start of the production, I may have epsilon as a one production, or else from the start of the production, I may have A, AA, or A. Any number of A's are possible, right? That can be written as small a. If after small a, if I write capital S, in place of S, if I substitute as epsilon, I will get A. Otherwise, in place of S, if I substitute AS again, I may get AA. Likewise, any number of A's are possible using this particular production P. That means that context-free grammar can be generated for this particular rule using these two productions, right? If you observe carefully, in this case non-terminals are nothing but V. What are non-terminals? Capital ES is the non-terminal. And what are terminals? Terminals are nothing but special symbol is epsilon comma A, and the P is production and S is my start symbol, right? See, any language which is accepted by context-free grammar, you can call it as a context-free language. Any language rule which is generated by context-free grammar, you can call it as a context-free language. This is what a formal definition of CFG.